fractions. Not anything new. We're just going to do a quick review. Remember that equivalent means equal or the same. They are fractions that are worth the same. Basically, think of it as cutting a pizza in different ways. If you cut a pizza, you can cut a pizza in half, you can cut a pizza in fourths, you can cut a pizza in eighths, you can cut a pizza in sixteenths. No matter what, you have one pizza, right? But it's just your pieces get smaller. The bigger your denominator gets, the smaller your pieces get. But if I still am going to eat half my pizza, I'm either going to eat 1/2, or if I cut my pizza into fourths, I'm going to eat 2/4. I am still eating the same amount of pizza, right? If I cut it into 16 pieces, if I'm going to eat half of it, I'm going to eat 8 pieces. All right? No matter what, I've eaten the same amount of pizza. Same thing with equivalent fractions. Basically, it's fractions that name the same amount. Where you might use that, if you're trying to divide things out evenly, if you have like 3 friends but 4 things, you might turn it into 12 so that you can divide it out. Each of you gets the same part of something out of 12, or you might, something of that nature is usually your best. If you have 3 friends, but, 1 piece of pizza, and you want, like, multiple slices, you could divide it into 12ths, and then that would work. Simplest form is essentially the smallest denominator and numerator that you can get. Smallest numerator and denominator. I'll leave it like that. The lowest you can go. The simplest you can go. Now, when we do simplest form, when we do an operation on fractions, add, subtract, multiply, or divide, our answer is always in simplest form. So if you're doing an adding problem, when you get all done, and I know you've heard this before, you get all done, your answer must be in simplest form. Now, it isn't going to always be your answer because sometimes it wants you to make a bigger fraction that's not equivalent, not in simplest, or that is equivalent but not in simplest form. Like when we do changing mixed numbers to improper fractions. That's not simplest form, but we're doing that on purpose. But if it doesn't give you directions and you're doing an operation, add, subtract, multiply, or divide, when you're done, your answer must be in simplest form. Really quick, we know how to make equivalent fractions. You're going to either multiply or divide both the numerator and the denominator by the same non-zero number. If you're going to multiply it by 2 on the top, you got to multiply it by 2 on the bottom. If you're going to multiply it by 3 on the top, you're going to multiply by 3 on the bottom. If you're going to divide by 2 on the top, you have to divide by 2 on the bottom. If you don't do that, your amounts aren't going to stay the same. Brandon? Well, not 1 technically, yeah. 1 just keeps it the same. Yeah, 1 doesn't do you any good, right? We kind of ignore 1 in a sense. Yeah, if I said 1/4 times 1 over 1, it's still going to be 1/4. So it doesn't really make you any changes. Good point. Think of it as doing clip art. When you're stretching clip art to make it bigger or smaller in Microsoft Word, as long as you grab the corner and pull, it changes the side and the bottom at the same rate, or squishes it the same rate. If you start pulling from just the side or just the bottom, doesn't the picture get all screwy? Yes. So, yeah. So equivalent fractions is basically saying I'm going to grab from the corner and I'm going to pull the side and the base by the same rate so that they stay the same. The picture looks the same. It's just going to get either bigger or smaller. That's kind of what equivalent fractions, that's another analogy to it in your real life. Now, we use the word scaling a lot, or you're going to start using the word scaling a lot. Think about on a map, the scale of a map. It kind of, it's 1 inch equals 1 mile. or such. It's keeping things, it's almost like making a fraction. If you're going to multiply, another word for multiplying is scaling up or scaling bigger. And divide is going to be scaling back or scaling down. And just like a map, you keep the scale the same. 1 inch is always going to be 1 mile or whatever. You're going to keep it the same. You're just either going to get bigger or smaller. So if you hear the term scaling up or scaling back, that's basically what you're doing, is making an equivalent fraction of some sort, either getting bigger or smaller. We did this actually with our ratio unit. When we did the percent one especially, like if I had 75 over 100 and I had something over 28, or yeah, something over 28, and we were finding that, we scaled back. Remember, we divided this into we made this into something that would go back and we could use to scale back up. Going from 100 to 4 was scaling back. And then going from 4 up to 28 was scaling forward. You did that already. Oops, that's by 25. Okay, sometimes when you work with numbers like this, sometimes you might have to scale back to find something that'll work. Like we couldn't just say, well, 28 times something equals 100. You couldn't do that and keep whole numbers. So you had to scale back. There's the other thing. These are whole numbers. 2, 3, 4. All right, because you could, technically, there is something out there that 28 times that number would equal 100. Technically, there's a decimal number out there, but that's not what we want. We want whole numbers. All right, so like looking at the 3 examples here, you can basically say to yourself, I went times 2 to go from 6 to 12 and 8 to 16. I went times 3. And these little arrows are showing your work. On tonight's homework, I'm going to split the difference with you. The first 2 parts, you're going to show me all the arrows and all the work. And then the last 2 parts, you don't need to. Okay, but we need to get in the habit of showing all of our work, which includes the little arrows, so that the person looking at your work, whether it be me, a friend, another teacher, a grader of a test or whatever, knows exactly what you did. How did that person go from 6 to 18? Oh, they multiplied by 3. All right? Obviously, we could assume that, but you need to be very clear. And don't forget that when I give examples on the board, a lot of times I use easy numbers just to make it so you understand the process. So on your homework or on a test, it might not be as simple as going from 8 to 4. It could be like from 122 to 15, or I mean, that's an example off the top of my head, which actually doesn't work. But okay, so don't just say, well, everybody knows 8 divided by 2 is 4. Just get in the habit of showing me those arrows, showing me that work, so that you have every single piece on that paper that you need to have. Remember, it's not just about the answers, it's also about how you got there. All right? Next page. Simplest form. Quick review. A lot of us don't do this process. A lot of us like take a shortcut and just kind of in our head say, oh, I can divide them both by this, and then I can divide them both by that, which is okay. But the real process to finding the simplest form of a fraction is this. Find the greatest common factor of the numerator and the denominator. Just like we did Friday. We either made our little chart and then our list, or we made the prime factorization factor trees. And then use that GCF to reduce, to divide the top and the bottom, the numerator and the denominator. Okay? So let's do the examples. Again, I know you can do these in your head. I know that you can do it without doing this, but I want you to do the example. Finding the greatest common factor. We're going to find simplest form of 20 and 28 using the greatest common factor. So we're going to make our factors of 20. What, you mean the factor tree? You can use a factor tree, yes, but I don't want you to just do the reducing without doing something to find the greatest common factor. I want you to be able to tell me what the greatest common factor is. Again, this is something I know that you can do in your head. That's not my point. My point is to show you how to do this. That's not the right. Whoops. Remember, use your process. Go right around in order. Now here's, especially if you're not sure, if you get two numbers and you just cannot think of a number that goes into both, you just can't do it. Just having a brain cramp or it's a difficult number, list your factors of each number. Do the process. Then find your common ones. And then just say, oh, the greatest common factor of 20 and 28 equals 4. So then you can go back up here and divide by 4. And that will immediately bring you to the simplest form. If you use the greatest common factor, you will be in simplest form immediately. You won't have to say, did I go far enough? Because a lot of us, this is what we do. We look at 20 over 28, and we say, oh, well, I can divide them by 2. Oh, and then 2 again. Sounds familiar, right? A lot of us do that. Again, a simple example. The biggest problem with doing something like this is a lot of times some of you will do it once, reduce once, and then either forget to keep going in the simplest form or miss, like they can both be divided by 3, they can both be divided by 5 or 7. Well, 5 is not hard, but 3, 7, 13. So when you think you might be in simplest form, you're really not. So that's really the big problem. And I know when you get, if you're going to do it in steps, you need to make sure that if you think you're done, you double check. Is this really simplest form? Can I divide them both by 3? That's a big one. Kids forget 3 all the time. They forget 7 all the time. Okay? Just because one's even, one's odd doesn't mean you're in simplest form. You're going to have 6 and 21. 6 over 21 can both be divided by 3, right? So just, you need to make sure that you are checking every step. This other one, 14, 1 times 14, 2 times 7. Again, I made this easy on purpose. Well, hello, Mr. Rush.
Technically, we're using it.
Okay, here we go. Shh, guys.
Yeah.
So, what's my greatest common factor of 14 and 49? 7. So my GCF is 7. So I'm going to divide them both by 7. Again, this is one I'm sure that you would have come up with in your head. My point is, this is the correct process of doing simplifying fractions. I know most of you can, especially the simpler fractions, you don't need to go through this whole rigmarole. But if you get to one that you can't figure out, this is how you would do it. You would list your factors, go through, find the greatest common one, divide by both. Sometimes you can't. Like if I'm doing like simplest form, if it's already in simplest form, the greatest common factor these guys have is 1. So can I reduce it anymore? No. All right. That really comes into play more when you have 2 fractions and you're trying to reduce both of them. Yes, Brandon.
Another way you can figure out like how you know this is say if both the numerator and denominator are prime.
Yes, if both the numerator and denominator are prime, it's definitely, but that doesn't even have to be. But yes, like 6 over 7 is in simplest form. But that is a good clue to double check. Okay, so that's pretty much, that's pretty much it. As far as your homework goes, this is a good quick practice of, hang on. It's a good practice of doing equivalent fractions. If you are struggling with your math facts, your multiplication facts, this is going to be difficult for you. If that's the case, you need to remember that you still need to be practicing those math facts. Okay, you're not done. Just because we can use a calculator for most of our work now does not mean you are not done trying to learn those facts, because you need to be able to be quicker, faster, stronger at those facts so that you can automatically see those facts in your head. You can automatically find a common denominator. As far as homework tonight goes, there's two different kinds of problems. The problems that are like this, and you're filling in the blank, I expect you to be showing your work. So you're basically going, well, I have to go this way, so I'm going this way. How do I get from 15 to 5? I divide by, that isn't going to work. That should be a 3. Divide by 5, so I'm going to divide by 5, and I get a 5. Okay? Those kind of problems, I want you to show your work. The simplifying problems on the second part, if you want to show your work, that's great, but you can, if you can do it in your head, I'm fine with that part. Okay? Do you understand? And I will take points off if I see people that did not do showing their work like I asked. Remember, you have to get in the habit of showing that work. It's not just the answer. You need to get away from the thought that I only need to worry about having the correct answer, because that's not what it is. It's all of it. So they're using the right process. Think of it as just making sure you get partial credit, if that's how you want to think of it. Whatever, you need to show me your process, not just a perfect final answer.